Hello and welcome. This is Safa. In this video, we're going to compare the step response of a first order system and second order system using MATLAB. This comparison helps us clearly see how system order affect transient behavior such as the overshoot and smoothness of response. Okay, here. First of all, we clear the workspace command window and close all figure. And now, here, let's define a first order system. We choose a time constant tau equal 1. Okay, this transfer function represents a classic first order system. It has a single pole which results in a smooth and monotonic response. Okay, and next we defined a second order system. Here omega n is the natural frequency and zeta is the damping ratio. Because the damping ratio is less than 1, 0.4, okay, this system is underdamped, meaning we expect overshoot and a slight oscillation. Okay, and here we display both transfer functions for clarity. And finally, we plot the step response of both systems on the same figure. You can see here. This allows us to directly compare their dynamic behavior. Okay, run. Okay, the blue curve, which is the first order system, you can see here, rises smoothly from 0 to 1 with no overshoot. Okay, the red curve, you can see here, representing the second order system, shows a peak above 1, followed by a small damp oscillations, and eventually settle at the same steady state value. Okay, this comparison clearly shows the higher order system can respond faster, but at the cost of overshoot and oscillation. Okay, thanks for watching.